In Activity 9, Tornadoes, students discover how tornadoes form, then reproduce them on a much smaller scale in the classroom. They first model a tornado by creating a vortex in 2 bottles of water and explore some characteristics of tornadoes. Finally, they discuss ways to stay safe during a tornado. You will need the following materials from the kit: Activity Sheet 9, Parts A and B, 1-liter plastic bottles, laminated United States outline map, package of erasable markers, assorted colors, top, and tornado safety tips. You will also need to provide crayons, food coloring, funnel, paper towels, pictures of tornadoes, roll of duct tape, pair of scissors, and tap water. To prepare for the activity, collect pictures and news accounts of tornadoes. Then, cut 8-centimeter pieces of duct tape and hang them from the edge of a table or desk for later use. Make a copy of Activity Sheet 9, Parts A and B, and the tornado safety tips for each student. Each team of 4 will need 2 1-liter plastic bottles, a box of crayons, and access to the food coloring and paper towels. For this activity, you will need a laminated wall map of the United States, erasable markers, and a spinning top. Make sure to also have tap water, food coloring, and paper towels available for students. To begin the activity, ask students, what is a tornado? Most students will know that a tornado is a powerful and destructive windstorm that travels across the land. Some other names for a tornado include twister, whirlwind, and cyclone. Discuss any experiences students have had with tornadoes. Then, share the pictures you have collected and read accounts of actual tornadoes. Ask students, what is the weather generally like when tornadoes form? Explain that tornadoes form when the sky is filled with thick, dark clouds, usually during a heavy rainstorm with thunder and lightning. Then, encourage students to recall what they learned about lightning storms in Activity 8. Students should note that lightning storms occur most often in the summer and are accompanied by high winds, which are caused by the upward movement of very warm, moist air. Ask students what happens when warm air rises. Students should recall from Activity 4 that as warm air rises, cooler air rushes in to take its place. Explain that if the cooler air rushes in quickly enough and from more than one direction, the cooler air will collide with other cold air masses and begin to twirl around violently. This collision causes the warm air in the middle to twist as it rises, forming a funnel shape. The cloud directly above the twisting column of rising air is called a funnel cloud, which sometimes hangs in the air, but other times touches the ground. If the funnel touches the ground, it is considered a tornado. Ask students, if a tornado is made of twisting air and air is invisible, why can you see a tornado? Guide students to understand that a tornado is like a giant vacuum cleaner. It sucks up dirt and debris from the ground. This dirt and debris, as well as raindrops from the clouds, are what give tornadoes their dark color. Next, distribute a copy of Activity Sheet 9, Part A, to each student, and 2 1-liter plastic bottles to each team of 4. Working over a sink or dishpan, have students fill 1 bottle 3/4 full with tap water and add a few drops of food coloring to the water. Next, distribute a copy of Activity Sheet 9, Part B, to each student, and a box of crayons to each team of 4, and instruct students to work in groups to make a tornado form in their bottles. Then, tell students to draw a picture of their tornado and answer question 2 on Part B of the activity sheet. When they are finished, make sure the necks of both bottles are dry and distribute a piece of duct tape to each team. Students should then place the empty bottle on top of the 3/4 full bottle, neck to neck, and tape the bottles together with the duct tape. The bottles should stay together and stand straight. Instruct students to turn their bottles upside down. While holding the bottom portion of the bottle steady, have them quickly make a clockwise movement with the top part of the setup and then let go. A tornado should appear. Discuss students' observations and ask, how is your tornado in a bottle similar to a real tornado? Students should conclude that the bottle tornado and a real tornado consist of swirling matter, air or water. Both form funnels that can bob or hang suspended from the base of the storm cloud. They both can touch down, then lift up again, over and over. Both tornadoes also die out when the swirling air or water slows down. Then ask students, how is your tornado different from a real tornado? Students should respond that the bottle tornado is made of swirling colored water, while the other is made of swirling air. and that unlike the tornado in a bottle, a real tornado is very tall and wide. A real tornado is taller than a skyscraper and about the length of 3 or 4 football fields. Other observations may include that a bottle tornado is shorter, and that the winds inside a tornado move much faster, up to speeds of 300 miles per hour, than the water in the bottle. Ask students, what number would you rate a tornado on the Beaufort scale? Explain to students that the winds in a tornado blow so hard they cannot be rated on the Beaufort scale, and must therefore have their own scale, which is called the Fujita scale. Ask students, does a tornado move in a straight line? Inform students that while the bottle tornado stayed in one place, a real tornado travels at upwards of 65 miles per hour. To demonstrate how a tornado moves, set a top in motion, gently blow on the top, and have students observe the path the top makes as it moves across the tabletop. The spinning motion of the tornado makes it wobble while the wind pushes it across the land. Explain to the class that a real tornado produces a deafening roar, and that the longer a tornado lasts and the farther it travels, the more damage it can cause. Then, discuss as a class the damage that a tornado can cause. Next, introduce the term waterspout to the class. A waterspout is a tornado that forms or passes over water. Just as tornadoes pick up dirt and debris, waterspouts suck up water as they move across the surface of a lake or ocean. They can also damage or capsize boats. Then, place a few objects on a tabletop. Spin the top again, blow on it to make it travel, and ask students to observe what happens to the top as it tries to make its way across the cluttered table. Students should note that the top bumps into the objects, causing it to slow down and eventually fall over and stop. Help students understand that tornadoes behave similarly. They travel easily across large areas of flat land, but are less likely to form and are more short-lived in regions where the land is uneven or where there are many things to run into, such as mountains, forests, and large cities. Draw students' attention to the wall map of the United States and outline the Great Plains region in the middle of the map. Inform students that the region has been nicknamed Tornado Alley because many tornadoes occur in this large area of flat land. Next, distribute the tornado safety tips and review it as a class. Finally, tell students that in the next activity, they're going to learn about another type of storm that has swirling, high-speed winds. To conclude the activity, have students empty their bottles, rinse them out, and set them upside down to air dry. Return all other materials to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.